Hello students, welcome back to the maths class. Again Navdeep Agrawal is here. Today I am going to explain a representation of the solution set on the number line. Students, in yesterday's video, I told you how to solve a linear inequation and how can we find the solution set with the help of given replacement set. Today in this video I am going to tell you how can you represent the solution set on the number line. In class 8 such type of questions you have done, but some different type of questions are coming here, but they are based on the questions which you have done in class 8. So with the help of some examples I will explain how to represent the solution set on the number line. So you see, first example is example number 7. You can see this example. Given that x belongs to real number, solve the following inequality and graph the solution set on the number line. This is the inequality. -1 is less than equal to 3 plus 4x is less than 23. X belongs to real number. This replacement set you have to keep in the mind. I will tell you, then solution first of all I will tell you, and then how to represent. So first of all, this is the combination. Here two parts are there. I told you in last video, such type of inequality is the combination of two inequations. By taking middle part with left term and with right term, you can make two inequations. So -1 is less than equal to 3 plus 4x, first inequation, and 3 plus 4x is less than 23, second inequation. Now separately you solve both the inequations. So constant term you take in LHS, so it will come -4 is less than equal to 4x. Here also constant term you take in RHS, so 4x is less than 23 minus 3, so 4x equals 20 will come. Now you divide by 4 both the sides, then -1 is less than equal to x, and here by 4 both the sides you divide, so x is less than 5 will come. Now you have to combine. Yesterday I told you how to combine the two inequations. So I told you first you write variable, again I am telling you, first you write variable x, then to the left side and to the right side less than sign you will put, and the number facing this open face is 5 you write to the right side, and the number facing corner means this one is -1 you write to the left side. So this is the inequality. Like this you can combine. -1 is less than and equal to sign is here at -1. So at -1 you can put equal to sign. So -1 is less than equal to x is less than 5, and x belongs to real number. Yesterday I told you in last video, then if x belongs to real number, then you cannot write the solution set in roster form. So roster form we cannot write, so we are writing in set builder form. -1 is less than equal to x is less than 5, and x belongs to real number. Now this is the important point, today's new point, how to represent on the number line. So you make one number line. You can see here, this is the number line. Here you can see this is the middle number, you can take 0, and to the right side of 0 positive numbers are written, to the left side of 0 negative numbers are written. In class 8 you have studied this thing. Now your inequality from -1 to +5. So at -1 you will make dark dot, at 5 you will make hollow dot. You can see this is dark dot and this is hollow dot. Now at -1 why dark dot, at 5 why hollow dot we have made hollow circle. So you can see here, if equal to sign is also there, equal to sign at -1 equal to sign is there, you can see here equal to sign. So at that place you will put dark circle, and where equal to sign, here you can see equal to sign is not there. At 5 x is less than 5, here equal to sign is not there, so hollow circle will be made in such case. And middle portion from dark circle to hollow circle middle portion, it will be fully darkened. You have to dark fully this full from -1 to +1 full space you have to dark on the number line. So like this you can make the number line. One more example I am going to take. This is example number 8. In this example you can see same question is there. Here in fractions numbers are given. You can see -1 upon 3 is less than equal to x upon 2, -1 whole 1 upon 3 is less than 1 upon 6, x belongs to real number. Grab the values of x on the real number line. Same question as 7th one. So first of all you separate two inequations. First inequation, -1 upon 3 is less than equal to x upon 2 minus 1 whole 1 upon 3, and second one, x upon 2 minus 1 whole 1 upon 3 is less than 1 upon 6. Now you solve, take constant term on one side, means in LHS you have taken two constant terms, -1 upon 3 plus 1 whole 1 upon 3 is less than equal to x upon 2. Now on simplification you will get 1 is less than equal to x upon 2 by cross multiplication, or you can say by +2 both the sides you multiply, then 2 is less than equal to x. Now you come to the second inequation, take constant term to one side, means in RHS you have taken 1 upon 6 plus 4 upon 3. After simplification x upon 2 is less than 9 upon 6, and after simplification it is coming, you can see x is less than 9 upon 6 into 2, and finally answer is 2 3s are 6 and 3 3s are 9. So x is less than 3. Now combination you will make. You can see you can combine 2 is less than equal to x is less than 3. I told you how to combine. Now from 2 to 3 you have to represent on the number line. So add two dark circle, because you can see 2 is less than equal to x. So equal to sign is there. So here add 2 dark circle is there. Now you can see x is less than 3, equal to sign is not there. So add 3, hollow circle will be there. And middle portion between 2 and 3 you have to dark fully, because it is the case of real numbers. So that's why 2 to 3 you have to dark. So you can see 2 to 3 you have darker. Now next example is coming, example number 9. In this example, list the solution set of 50 minus 3 into 2x minus 5 is less than 25. Given that x belongs to whole number, also represent the solution set obtained on a number line. So here real number case is not there. You have to keep in the mind, again and again I am saying, if real number case is there, then solution set you cannot make in roster form. If real number case is not there, whole number case is there, natural number case is there, integer case is there, then you can make the solution set in form of in roster form, you can say, we can say. Next, if rational number case is there, then also you cannot make solution set in roster form. Now you solve 50 minus 3 into 2x minus 5 is less than 25. First of all you multiply inside the bracket by 3. So 50 minus 6x plus 15 is less than 25. Now constant term you can take to RHS, right hand side. So minus 6x is less than 25 minus 65. Minus 6x is less than minus 40. Then now you are dividing both the sides by minus 6. So inequality sign will change. In last video I told you, if you divide or multiply by a negative number, then inequality sign changes. So here x is greater than 6 whole 2 upon 3. Now you have to write the whole numbers which are greater than 6 whole 2 upon 3. 6 whole 2 upon 3, you can say 6.666 like this. So the numbers which are greater than 6.6 you have to write. So 6 greater than 6.6, 7 will be there, 8 will be there, 9 will be there, and so on. So many numbers from 7 to where we don't know, to infinity we can say. So now how to represent on the number line? You can see here, you can see This is the number line. 7, add 7 dark dot, add 8 dark dot, add 9 dark dot, and 3 more dots you can put like this. 3 more dots. These 3 dots shows continuity. Only numbers you have to dark, not the portion between the numbers. Between the numbers, whatever portion is there, you will not dark, because it is not the case of real number. In case of real numbers, only middle portion will be darkened. Now 7, number 7, number 8, number 9, you have to dark, and 3 more dots you have to put over the line, so that you can show the continuity. Numbers are going till infinity. Next example is coming 10th. Solve and graph the solution set of 3x plus 6 is greater than equal to 9 and minus 5x is greater than minus 15, where x belongs to real number. Again, it is the case of real number. Now you have to pay attention. Here and is given. Here and is given. So in case of and, what will you do? First of all, you solve this inequation. This inequation, 3x plus 6 is greater than equal to 9. 3x is greater than equal to 9 minus 6. 3x is greater than equal to 3. X is greater than equal to 1. Next inequation, minus 5x is greater than minus 15. Both the sides you divide by minus 5. Inequality sign will change. X is less than 3. After solving for both the lines, for both the inequations, you make separate lines. So for first inequation, it is greater than 1 or equal to 1. So it is equal to 1. So add 1 dark dot, and it is greater than 1 till where we don't know. So from 1 to last with arrow you will dark the portion. In next question, in next inequality, x is less than 3, so not less than equal to. So it means that at 3 you will make hollow circle, and the portion which is less than 3 till arrow you will dark, because it is the case of real number. Now and means common values of both inequation you have to take. So how to take common values? You see here, you can see here 1 is there. Here you see 1 is there or not? Yes, 1 is there. Here in first case, in first inequation, 1 is included. In second solution set, 1 is also included. So 1 will be common from both the solution set. Now after 1, 2 is there here, and here after 1, 2 is there. Here after 1, 3, after 2, 3 is there. Here also 3 is there. But you can see in second solution set 3 is not included. In first solution set 3 is included. So 3 is not common, you cannot say. But the values less than 3 are common. So from 1 to 3, from 1 to 3 means solution set of both you can make 1 is less than equal to x is less than 3. So and means intersection. Intersection means common values of both the solution sets you have to take. So common values, how can you find? Like this I told you, 1 is less than equal to x is less than 3. 1 is included in both the solution set. 3 is not included in both the solution set. So that's why we are not putting equal to sign at 3. But less than 3, all the values are common. So here you can see the line 1, 2, 3. The portion between 1 and 3 fully you have to dark, and add 1 dark circle, add 3 hollow circle. Like this you can solve such type of question. And means intersection, again I am telling to you. Or means union. Union means combination of both the solution side you have to take. Second 11th example is coming. You see, solve and graph the solution set of minus 2 is less than 2x minus 6, or minus 2x plus 5 is greater than equal to 13, where x belongs to real number. You can see the solution. Minus 2 is less than 2x minus 6. Solve it. Constant on one side. So they are taking actually RHS into LHS and LHS into RHS. Yesterday I told you the property. Then inequality sign will change if you do so. Then 2x is greater than 4, x is greater than 2. Now second inequation, minus 2x plus 5 is greater than equal to 13. So after solving, it will give x is less than equal to minus 4. Now separately, both the solution set you show on different number lines, separate number lines. So first one, greater than 2. So add 2, hollow circle, because it is not greater than equal to. So more than 2, more than 2 means after 2 fully portion with arrow you have to dark. In second case, less than equal to minus 4, x is less than equal to, so add minus 4, dark circle, and the portion which is less than minus 4 till arrow fully you have to dark. Now I told you or is given, or, so due to this or, you have to combine both the solution sets and you have to make one common line. So you see, after combining, x is greater than 2 or x is less than equal to minus 4, both the portion will come together and this is the number line. You can see here on one number line you can show both the solution sets. Now next question is coming, question number 12. Given p equals x such that 5 is less than 2x minus 1 is less than equal to 11, x belongs to real number. Q equals x such that minus 1 is less than equal to 3 plus 4x is less than 23, x belongs to integers. Now you see, first you solve first inequation for p, minus 5 is less than 2x minus 1 is less than equal to 11, where x belongs to real number. So this is the combination of two inequations, separate two inequations, 5 is less than 2x minus 1 and 2x minus 1 is less than equal to 11. After solving, 3 is less than x and x is less than equal to 6. Combine them, 3 is less than x is less than equal to 6, x belongs to real number. Make the lines number line. So 3 to 6, 3 to 6 means add 3, hollow circle, because equal to sign is not there, add 6, dark circle, because equal to sign is there, and middle portion you have to dark because it is the case of real number. Next for q, you can see for q inequation is given minus 1 is less than equal to 3 plus 4x is less than 23, x belongs to integers. Now separate the inequations, minus 1 is less than equal to 3 plus 4x and 3 plus 4x is less than 23. Solve it, minus 1 is less than equal to x, x is less than 5. Now combine, minus 1 is less than equal to x is less than 5, x belongs to integer, it is the case of integers. Now integers from minus 1 to less than 5 you have to take, from minus 1 to less than 5. So from minus 1 to less than 5 they will come minus 1, 0, 1, then 2, 3, 4 and 2, 3 and 4, because less than 5 means till 4 you have to take, minus 1 to 4 you have to take. Now you represent on the number line, minus 1, 0, plus 1, plus 2, plus 3, plus 4, because here dots will be represented only because it is a case of integers. Now common portion you have to take, p intersection q, you had to find p intersection q. From both number line you can see what is common. 3, here you can see 3 is not there, here 3 is there, so but 3 is not common. 4, 5, 6, here 4 is there only, 5, 6 is not there, so 4 is common in both, you can see. So 4 will be the intersection of p and q. So you can see here it is 4, answer is 4. So with the help of these examples, students, you can do all the questions of exercise 4th B. I hope you have understood all the examples. If you have any doubt, then you can ask in comment. Through comment I will clear your doubts and you solve the questions of exercise 4th B. So thank you and have a nice day.